Hi. So in this video we'll discuss sorted set. In the previous video we discussed sets. So it's similar to set, but in sorted set you can basically add a particular score to every member that you're storing, right? So you can think of it in two ways. So let's say you are designing a leaderboard. So in leaderboard you want to store a member, and for every member you want to store a particular score, right? So you wouldn't be using a simple set for that. For that we will be using sorted set. And let's say you have a priority queue. Basically you have some tasks in your priority queue, and every task has some priority score attached to that particular task. So for these two scenarios you would be using sorted set instead of set, right? So in simple language, whenever you want to add a particular score to the member that you're storing in a set, you would be using sorted set, right? So this is one example. Let's say you have a leaderboard set where every member has particular score, like Alice has 1500, Bob has 2300, Carol has 800. So you can store this kind of data in this sorted set data structure, right? And by default, whenever you will be checking, let's say you want to check all the members that are present in your leaderboard, they will by default be sorted in the ascending order. So that's basically out of the box you get, right? And Redis maintains the order on every insert, right? So why does it matter? So it matters because it can solve a lot of problems for you. Let's say you want to see who are the top 10 players in your leaderboard. If you want to check rank of a particular member in your leaderboard, right? Let's say you want to see which particular task you want to run. For that you can maintain a priority queue using sorted set, right? So there are so many production scenarios where you can use it. And so in simple language, it's just wherever you are storing score or a number to each member that you want to store in a set, you would think of using sorted set, right? So there are some basic commands which you can use on sorted set. So let's say you want to add a member and a score to a sorted set. How you would do it? You would use ZADD. If you want to remove any particular element from the sorted set, you would use ZRANGE. If you want to see a score of a particular member, you use ZSCORE. If you want to see how many members are present, you can use ZCard. If you want to see the rank of any member, you use ZRANK. If you want to see the rank in descending order, you can use ZRANK. And you can also do some incremental operations on the score, right? So yeah, let's do these examples, and then it will be pretty clearer. So what we can do is we can I'll open my terminal, and you can open the Redis CLI. It's already opened. So what you can do is you can let me clear this. So you can do, just a second. So okay, let me clear this. I'll just open it in a new terminal. You can write Redis CLI, and here let's add a leaderboard sorted set. So you can do ZADD leaderboard, and in this I'll store the score, let's say 100, and the name of the member, let's say Alice, and I'll store another member score here. Let's say another person has 150 score, its name is Bob, and another person has 50 score, its name is Dave, right? So if you want to see all the members, you would use Z members leaderboard, right? Okay, I think it's what's the command? Z. Okay, if you want to see all the persons, I think it would be, okay, it's actually ZRANGE, not Z members. Sorry, that was for this set. So what you can do is you can do ZRANGE. You can provide your name of your sorted set, and then you can provide the starting and ending index. So I want to see the full, so you can do 0 minus 1. So it will show all the members that you have in your leaderboard, right? The next command is, let's say if you want to see a score of any member, right? So let's say I want to check the score of, let's say I want to check score of Bob. So as you can see, I'm getting the correct score that I stored, right? Let's say I want to check the score of Dave, so it's 50, right? So you can even check the score as well of any member. Next command is, let's say you want to see how many, like what's the length of this particular sorted set. You can do ZCard leaderboard. So right now we have 3 members in the leaderboard, and let's say if you want to check rank of any particular member, so let's say I want to check what's the rank of Bob. So he's basically at the 2nd position. Let's say I want to check rank of Bob. Sorry, I want to check rank of Dave. So he's at 0th position. That means he's at the top. But you can see he has the least score. But then why he's at the top? Because by default sorted sets are sorted in ascending order, right? So that's why. And then yeah, you can even remove particular member from the leaderboard. Let's say I want to remove Dave from the leaderboard. So if you check the leaderboard now, you only have 2 members present, right? And then you can also do the reverse ranking. So by default here ranking was sorted on the ascending order. Let's say I want to do it on the descending order, so you can do ZRank leaderboard, right? And then you can provide the member. So let's say I want to check so who has the highest score. Bob has the highest score, so it would be at the 0th position, which is at the top, right? And yeah, and you can also do some incremental operations. Let's say I want to increment let's say I want to increment Bob, or let's say Alice score by, I don't know, 20. Error value is not, just a second. Okay, leaderboard. Okay, first you provide the value, so I'll provide the value and then I'll provide the member. So basically I'm telling increase Alice score by 20. Cool. So yeah, these are some of the commands which you can try and do a hands-on on it, right? There are some range queries as well, which is a killer feature. Let's say you want to check the full leaderboard and rank it, you know, so you can use ZRange, which we have already discussed. So if I run this, you get that Alice is at the top and then Bob, right? And you can even do the reverse range. We can just write ZRange leaderboard 0 to -1. So basically right now Bob is at the top. You can even do let's say if you want to see the scores as well, you can do with scores. So Bob has 150 score, Alice has 120 score, so that's why Bob was at the top, right? Cool. But if you don't use ZRange, you just use, let's say, normal ZRange, you see you get Alice at the top because by default sorted set is sorted ascending order, right? So yeah, I think we discussed all the commands, and yeah, you can even find ranges. Like let's say you want to find which members in your leaderboard have score in this particular range, so you can use even a ZRangeByScore command. So let's say I want ZRangeByScore leaderboard. You can provide the minimum and maximum value between which your member score should be present. So let's say I want between 90 to 120 with scores. So as you can see, only Alice has score between 90 to 120, right? If you increase this maximum value, let's say 150, now you will be getting Bob as well, right? So yeah, you can do operations on score as well, right? And yeah, there's another ranking as well, which is lexicographical ranking. This is mostly useful when you have, let's say, 2 different members with same score. So you can do one thing. So right now let's add one more member with the same score. Let's say I add leaderboard, and then I add the same score which already exists in my leaderboard, which is 120. And for this, maybe I add a different member, maybe, I don't know, Arun, right? So what happens is, if you check ZRange now, you'll see it sorts it in the lexical order, right? Because Arun is lexicographically greater than Alice, basically alphabetical order, you mean, right? So yeah, from the alphabetical order perspective, Arun comes after Alice, so that's why Arun is coming later on. You can also check this example. Let's say you add one more same score, right? And you add the same score, and let's say you add someone whose lexical order is less than Alice. So let's say you add ADF. So if you do the sorting for this, you'll see ADF comes at the top. So yeah, there's this third sorting as well, which happens on the lexical order, alphabetical order, if scores are same, right? And then you have pop and blocking pop commands as well, right? So yeah, basically if you want, let's say you want to remove the member who has the least score, so you can do zpop min, and I want to basically remove one person from the leaderboard who has the lowest score. So right now ADF was at the top with the least score, so it was removed. You can even mention count as well. If I mention 2, it will, you know, remove the 2 persons who has least score, right? And yeah, zpop max command is same. Basically with the highest score, if you want to remove someone, you can do that. And then you have a blocking command as well, right? Let me add members again, then I can show this example. Cool. So let's say I want to remove someone from the leaderboard who has maximum score. So as you can see, it removed Bob because it had the highest score, right? And you can use bzpop minimum as well, which is the similar command to zpop, but it's a blocking command. So you can write bzpop minimum leaderboard, and after this you can provide the timeout, right? So although it won't be waiting for the timeout because it was already able to, you know, pop someone, but if let's say this sorted set was empty, then it would have waited 10 seconds to remove this you know, lowest score member, right? And you can even combine sorted sets. So let's copy this command. So in the first sorted set you have likes stored. So for the post 1 you have 10 likes, for the post 2 you have 20 likes, for the post 3 you have 5 likes. And I'll also store shares for every post, how many shares you have. Okay, so let's say you want to find engagement. So generally how engagement is counted, you basically sum up likes and shares for each post. So what you can do is you can do ZUnion, right? And I'll also use store after this. So basically I would be you know, doing the sum of likes and shares and would be storing it in a new sorted set. So let's give it name engagement, and here I'll provide how many keys I want to merge. I want to merge 2 keys. First key name is likes, second is shares, right? So if you check the engagement sorted set now, you will see you have 3 posts in it, which is sorted in ascending order. We can also check the scores as well, which is the engagement score. You'll see post 1 has engagement score 13 because when you sum it up, 10 plus 3 is 13. On post 3 you have 8 plus 5, which is 13. On post 2 you have 21. Let's say I want to see which is at the rank 1. You can do ZRANGE engagement 0 to -1. You'll see post 2 has the highest engagement score because if you sum likes and shares, it's the highest engagement, right? So in this particular scenario also you can use a sorted set, right? And which is genuinely very powerful, right? And yeah, you can use sorted sets in production in various scenarios. You can use it in leaderboards, you can use it in time series events, you can use it in priority queues, sliding window rate limiter, right? There are so many production examples. Cool. So now the main topic comes how Redis store internally stores the sorted set under the hood. So it has 2 different encodings. First is listpack and second is skip list, right? You can even check it here. So if I check the object encoding of engagement, you'll see by default it's listpack, which is the smallest encoding which it uses for sorted set. And if this sorted set was bigger, it would have used skip list, right? Basically for larger sorted sets. So yeah, and also Redis provides a threshold for this. By default it's 128. You can even check it. Let's say in your Redis you can do config get, And yeah, this is the name of your configuration. So basically it tells you can store at least 128 entries in your smallest sorted set, and if it exceeds it, it will basically be turned into the skip list, which is used for larger sorted lists, right? And yeah, so listpack is, obviously we have discussed it in the previous videos as well. It's kind of like a compact array storing all your entries in a single cache line, right? And skip list is kind of like a linked list, right? So it is used for bigger sorted sets. So skip list is kind of like a combination. So it will store the members in a skip list, which is a linked list, and for the score it will use a hash table. So for every member it needs to store score, right? So for that it will use hash table. Cool. And yeah, you can also understand the skip list in this way. So skip list is kind of like a layered linked lists. So yeah, so let's say you have these many members in your sorted set. So for all the members it will use linked list to store it, and it stores all the members in various layers. So the first layer will have all the members, and the second layer will have only few members from this particular list, and so on and so on, right? And this is beneficial in terms of, let's say you want to search any member or insert any member. So these layers are beneficial there, and that's why it's almost O log n operation, right? Cool. So yeah, these are some of the thresholds you can check. I'll also be sharing this notes in the YouTube video description, and you can see some performance criteria over here. Just a second. Yeah, so these are some of the performance metrics for the operations that Redis provides that you can perform on sorted set. So addition, removal, increment, all are log n operations because of the linked list approach which we just saw here. And then you have ZSCORE, ZCard, which is almost like O1 operation because it's just a hash table lookup. ZRANK, ZRANK, all are log n operations. So basically all operations that sorted set provides are almost all log n. Only ZSCORE and ZCard is like O1 lookup, which is really cool. And yeah, when you should not use sorted sets, you should not use sorted set when you only need uniqueness. You don't care about the score and anything else, so don't use sorted set. You can just use a regular set, right? You don't care about the order and anything else, then use set, right? Yeah, so yeah, just a recap. Sorted set is basically similar to set, but you can store members with scores in it. And these are some of the commands which we discussed and which we also, used in the terminal. And yeah, internally it used listpack for smaller sets, and for bigger sorted set it used skip list and hash table combination. And all the operations are almost O log n, right? And yeah, so I hope this video was useful and you understood in depth sorted sets, where you can use this in production in various different scenarios, and what are the various commands that Redis sorted set provides you. So yeah, that's it for this video. Stay tuned. Thanks.